Okay, it's been a while again. We are still working on the new CNC machine, getting it installed. The big holdup right now is insurance adjusters. We're trying to make a little bit of a claim to recoup some of the labor that we're gonna have to put into this thing to get the rust out of the machine, both in the coolant trays and on the table of the machine itself. In the meantime, a friend of mine brought me a transmission. So he has a little maybe 11-second Nissan 240 turbocharged with a Nissan motor that destroyed the transmission. So he picked up this 300Z twin turbo transmission, brand new. And what we're going to do, since he's already sheared off all the bolts on the flywheel, because with the adapter plate that you're required to run, with this adapter plate being a 1/2 inch thick, you have to space out the flywheel a 1/2 inch. Now your bolts are incredibly long. So even with just the 300 to 400 horsepower this thing makes, and a dead hook, the wrong clutch for drag racing, a dead hook, it just sheared all the bolts right out of the crankshaft. So what we're going to try and do is get rid of the spacer behind the flywheel. We're going to go ahead and cut this guy in half and remove this thickness of material from the top side of this transmission case. So it's not just a bell housing, it's actually the whole case. So we got to break this thing in half, take the case over, stand it up in the Bridgeport, and remove very accurately this thickness of material. So that's the next fun little project. We'll see how far we get tonight, and we'll probably run into tomorrow at least, if not more. So we're going to start by flipping this guy over, pulling a drain plug out, and in the shop here I've got this big vacuum container. I can just suck the oil out of this thing, so I don't have to hold it up and try and drain it. So that's what we'll do next. And I gotta add, I've never worked on one of these transmissions before, ever. So I've already got that a little bit loose. So let's pull the drain plug out. Hopefully I've got it tilted over far enough. Looks like it's good. So we got a little bit of metal on it. And we'll go ahead and get our little vacuum tank going. And yeah, should work. Probably 90 weight or something. Most of my experience is with T5s. Back in the day, Mustangs. I don't know how many T5s I've had apart. Okay, I pulled out the clutch fork and the release bearing. Got that out of the way. Next I'm going to pull these bolts and pull these. I'm guessing this is a bearing support. Up here, this looks to be the shift rail. So we'll see. And then what? Oh yeah, it's loose. Should come right out. There we go. Little bit of oil on there, but brand new basically. Got a bunch of chips of metal all over the grease from the throwout bearing, and that's from shearing the bolts off. We'll clean that up before we put it back together. There's looks to be an MLS gasket, so we can reuse that guy. Wipe up the oil. And I believe what we've got is some snap rings, or a big snap ring here, and then snap ring there holding the shift fork in. We will see what we can get out. Okay, got a little closer view here. We're going to take this snap ring off the shift rail there, and to do that I've got these snap ring pliers. Basically working around the camera here, but get them in there, get them in the hole, and just expand it out, pull it off, just like that. It's got a ledge it sits against, and it is directional. It looks like it's got a flat machine face that goes in. Now this external snap ring doesn't have the little holes like this guy does, so for that what we need is some of these flat paddles. These are right there. So we just get in there and expand that guy out, sort of. Fun. It's got oil all over it, so it wants to stick. I might have to get a little pick behind it. So I've got that half off now. I just use these guys to spread it out, and then a pick to get in behind it, hooked it and pulled it off. Once you get it half off, you should be able to just kind of work it around like that. Doesn't look to be directional how it goes back on. And I believe this should come out. Okay, so we separated the bell housing, or the front part of the case, from the rest of the transmission. So now we're going to go ahead and figure out where the cut needs to be on this guy, and that will drive where the cut goes on this guy. Okay, so we cut the adapter plate at the separation line between the engine block and the oil pan. So basically, we're going to cut the bell housing down to simulate this thing being in there. So basically, it will rest down flush, and then this will all match up with the oil pan on the engine. So we've got a mark on here. We've got the table lowered way down, and we're just going to cut everything from here up to this thickness. So we got to get this thing toe clamped down so it's flat. We'll cover up inside here because we still have some bearings in here that we didn't want to take out, push out, press out, whatever it took. And yeah, we'll get our toe clamped down and make some cuts. Okay, we got it all toe clamped down in the Bridgeport. Feels to be pretty solid. We'll see how the end mill works. Now we have to measure the adapter plate for thickness, indicate this is 0, and then take everything off down to the line, from that end down to the line. So we're going to use a helical 4-flute with a corner radius. This is cast aluminum, so a 4-flute will do just fine in this. And we're hand feeding, and we're turning at a pretty low speed, so we'll be just fine here. with this little helical. All right, so now I've got the whole head moved back to the point where it will cut from here all the way to here. The next thing I want to do is set up the DRO with X and Y zeroed out on the center of that dowel hole right there. So when we cut this, we're going to cut most of that dowel away, if not all of it. So what I have to do is go back through and do a press fit 12 millimeter hole right here. And I want to go ahead and just drill through so that that dowel can be knocked out in the future if we want to do that. Okay, got everything locked down, and I have an end mill, 1/4 inch. Will be just fine for a little clearance hole should we ever want to push that dowel back out. It's going to be press fit into the transmission. So yeah, we'll just run this little end mill through, make us a hole. Now we've got to do press fit 12 down through here, so I'll drill and then probably have to make a very short reamer for this and run a reamer in there. Okay, so we got the dowel opened up. That's a 12 mil. It's a nice tight fit. Had to grind an end mill down. 1/2 inch end mill, had to grind it down because I needed something very, very short. So I couldn't use one of my reamers. It's a good fit. And we made a couple of passes on the cut, and I've got 475. I need to go to 508 is the number, but we're just going to do 475 and then we'll do some cleanups. So and of course on this we have auto feed. So we've got the speed and feed set, so just kick it in gear. Kind of slow, we're too far away. And that's it, over and over and over. All right, we got it all cut. Bell housing is cut. The adapter plate is cut in half. And here we've got the little block plate. Kind of fits in about this position here. You can see where he marked kind of where the engine to oil pan separation line is on both sides. And we should be good there. So now what we have to do is drill and tap the adapter plate for the starter bolts. So we're just using the block plate to kind of find the center of those things. I'm going to look at doing transfer punches to get the true center of that guy, and we'll go from there. All right, so we got it off the mill, got it sitting on the table, and looks like to me that this thing's only going to use this one bolt right here in the oil pan to locate this thing, or to bolt it down to the engine. This might be a locating dowel, but I'm not sure. It looks like it's been kind of hammered up in the past, so not sure what's going on there. Anyways, Elliot gave me some marks. I've redone them just a little bit from what looks like it should be. I've been using basically a dowel in all these holes to make sure that everything will go. And these are my new marks. And what I'm going to do is I've got this spaced up just a little bit right here, just a tiny spacer, so I can use a transfer punch. So this transfer punch fits this hole really nicely. We'll drop it in there and give it a tap, and those will be my 2 holes for the starter. Okay, so I got the adapter plate mounted back on the table here, the Bridgeport. Chuck in, and I've got just a little piece of material that's turned down to a good point. And from my transfer punch marks, I'm going to just touch this guy off into the little hole, and that's going to tell me I'm dead center. So a lot of play in, feels pretty good. So then what I do is on the DRO, just center it out. That's the location of the first hole. So this has to be tapped for the starter. So the starter is, I've checked, it's a 10 millimeter bolt. So this has to be, from what I understand, this has to be clearance hold. Probably all of these will clearance them. And this has to be tapped. Starter is going to mount from the transmission side, I believe. Maybe it's the engine block side. Anyways, that's what I was told we got to do, so that's what we're going to do. Got all my drills set out, so I'm going to do a little pilot drill just to get this guy started nice and straight, because I don't have a stub length drill. So this guy could wander a little bit, so we do this first, then a Q drill, and then my 10 millimeter tap. And I'm going to power tap this right in the Bridgeport. So we'll go through the whole process on this guy. Okay, here's my little center finder device. I'm going to move the table over, find the hole center. Feels like it right there. Yep, that's it right there. So we'll just lock the table. And do a little center drill. And a drill. And a tap. It's not a tapered tap. So We'll see. It might slip a little bit on me. Might have to take 2 pecks at it. A little bit of dirt. Got about halfway. Drop it in the existing thread. Come on. There she goes. Come on. Not the nicest tap, but it works. And then while it's located, I can just put a chamfer bit in there and just give it a little kiss. Make the hole nice. And that's my whole workflow for that. Okay, so it's the next day. We ran out of daylight and just got way too late. So the mounting plate has been drilled and tapped for the starter, and now what we have to do is pop a hole in for clearance for the nose of the starter. Okay, so what I've got is I've got a hole saw just in the chuck. It's actually got a 6-sided shoulder up here that goes in the chuck. I can't put it in a collet well, so this will be just fine for this. We're going to feed this really slow. I've got the pilot drill out. Don't need that. I've got the table locked down. I've got this in place, and yeah, we're just gonna clear the chips as we cut, and just spin this really slow and feed it through. Next thing we got to do is clearance hole the starter. I was a little against this idea because now you have to have a custom starter, or at least have a pistol drill handy with a 10 clearance drill to open these up if you ever need a starter in the future. Anyways, pistol drill, that's not what we do here. So got this little fixture set up. Got the starter clamped in there. I'm using the same drill I just used on the adapter plate to drill to tap drill for the 10. So I will check clearance on that. So once that guy just runs through there nice and smooth, not dragging on the walls at all, I can change to a 10 clearance drill and blast that out. And I'll do that on all 3 holes. And this job should be done, except for reassembling the transmission. Okay, we got the bell housings all cut. I got the adapter plate bolted on just so it gives us something to grab a hold of. Got these mating surfaces cleaned up a little bit. Got some gray RTV, and we're gonna put a little sealant, a little layer of sealant on here, and reassemble this transmission. Okay, we got the case bolted back together, and now I'm going to take these guys here, snap ring pliers. Going to put them in there. Going to spread this out and feed it around the main shaft bearing. Kind of doing this around the camera. And there we go. Spread that out. And there we go. Make sure this is all the way in. Right there, locked in. Okay, so we got our snap rings on the main shaft, the input side, and there's quite a bit of end play, you'll notice. What looks like what constrains that is the cover. There's a machine surface right here, so that's going to establish the end play of the transmission. So got our little gasket. It's an MLS gasket, so we can reuse that guy, and that guy just goes on just like that. Long bolts go up top. Got to line our gasket up. All right, the three bolts down on the bottom here, they all had, you know, Nissan's version of Loctite on there. So we've got some 262. Just put a little bit of that on each one of those three. I guess more important around the counter shaft, why they wanted just the bottom ones done, I'm not sure, but going back with it. And then all the bolts are the same. These guys here. And go ahead and torque those. Okay, we got the cover bolts all tight. We'll just take a dab of grease, put it on here. Too much is just as bad as not enough. It's just going to attract all kinds of dirt. This thing's brand new anyways. So there's a clip that retains your clutch fork on the ball. So we got to get that in there. Typically you'll just assemble that little clip and just pop it over the ball. Yeah, I guess like that. And that'll hold it on the ball for you. So what's the secret here? Like that. And then just give it a push. You can spread those things out a little bit if you want. Like that. Money. Okay, so that's it. Nissan 240 adapting a 300ZX twin turbo transmission to it. So this adapter kit was already purchased, and it had a complete ring, basically top and bottom, and it's about a 1/2 inch thick. And what that did was that required the flex plate, or the flywheel in this case, to have a spacer equal to this. That puts a lot of shear strength, a lot of shear stress on the bolts, and snapped all the bolts off. So what we did was we recessed the adapter plate into the face of the transmission. Now we've eliminated the spacer that goes on the crankshaft, and now we can use the high quality ARP bolts, and no more shearing those bolts off. So also drilled out a starter, so now that can bolt on here if it needs to, but there's some thought that maybe the starter for the 300Z will work. We'll have to see if it meshes properly with the teeth. Depth is all correct. So it's a bunch of different parts. They're all very similar, but you never know. But that's it. That's all the work it took to modify one of these guys.